Hello guys. Okay, so today we are talking about memory cage, or let's say memory cage and memory and mapping techniques. So we will begin with the we will begin with what is cage memory or memory cage or anything or how you pronounce it. So cage memory is a small and fast memory located close to the CPU. Its main job is to store frequently used data and instructions so the processor can access them quickly without going back to main memory. That's the RAM every time. So it basically means that it's a small and fast memory located to the CPU, and then its job is for it to store your frequently used data, like the things you commonly use on your computer and instructions you commonly give to your computer, so that you'll be able to get to them quickly, so that you won't be going to the RAM in every time you want to access them. Okay, so the main purpose of the cache memory is to reduce the time to access data from the main memory. Like maybe you want to get some pictures from um hard disk, but you see the cache memory has just stored the pictures onto a section in your file explorer on your computer, which is called pictures. So that with that you'll be able to get your pictures very easily and fast. So why use cache or anything? The RAM is slower than the CPU. So you see, before you get to the RAM, it takes a lot of time and that stuff. So you need a cache to get to those stuffs early. Then cache help by storing recently or frequently used data. That's what I said earlier. It's like the things you use on your computer. That's what it stores and other things. Then it improves speed and performance of the system. So it improves your speed and your performance. That's at times when your cache becomes too loaded on your phones, like even in your browsers, there is a section where it will be like clear cache, so that the application or anything you're doing could move really fast, because at times the RAMs are really slow. And there are three types of cache mapping techniques, and there are three main types used to store data from main memory to cache. One is the direct mapping. Each block of main memory maps to only one cache line. So let's say one block maps to the second block. So that's in the pictures behind me. You see, block one will match to um only one cache line. Block two to match only one cache line, so that everything will be in order. Then we have the associative mapping. And the second one, a block of memory can be placed anywhere in the cache. So let's say but before, there's the advantage of the direct mapping is simple and fast. It's very simple and fast. And its disadvantage is higher chance of conflict, because you see, because it's working so fast, it can just move about. It's like you doing something really fast, then you just mix it up. You see, yes. Then the associative mapping is a block of memory can be placed anywhere in the cache. So you can just map it anywhere. It doesn't necessarily mean that okay, map it to section A or map it to section B. And the advantage of the associative mapping is flexible and efficient, because this one you are not entitled to only specific block. You can give it to any block, or you can just. And the disadvantage for this one is slower search time. You see, maybe when you're searching for something in your file explorer or in your settings or anything there, maybe when you type maybe camera, it will take a lot of time to bring out the camera settings. So yeah. And C, we have the set associative mapping. This one is a mix of the above two. That's the direct mapping and associative. So it's a mix of the direct and the associative. So cache is divided into sets, and each block maps to a set but can go to any line in that set. And the advantage for this one is balance, speed, and flexibility. So this one, because both directive and associative are working together, the advantage is your speed and getting your things fast will be very easy and flexible. And to be at a normal speed, it won't be maybe higher or lower. You see, yeah. And the disadvantage is more complex than direct mapping. You see, with both direct and associative with together, doing the work as a cage, it's more complex because it's like you putting an easy person and a strict person together. You see, they'll have conflicts and other stuff, so it will be very complex when you're dealing with them. And we have a summary table. I have a summary table of the mapping. So the summary table includes the mapping type, flexibility, speed, and complexity. So we start with the direct mapping, which is under the mapping type. Then along the direct mapping, we have low, which is under the flexibility. So with direct mapping, its flexibility is low, its speed is very fast, and its complexity is low. With associative mapping, its flexibility is high, speed is slower, and complexity is high. But with set associative mapping, its flexibility is medium, speed is fast. This one is not very fast, it's fast, and its complexity is medium. So now with the conclusion of everything, cache memory is very important in the system. Understanding these mapping techniques helps in knowing how data is quickly accessed to boost performance. So in all, I'm trying to tell you that with a cache memory, you'll be able to access things like commonly used. Like example, I'll use myself as an example. Mostly I use PowerPoint, so where I save my slides, my um, presentation and other stuff. I've saved it on the computer, but mostly I have a lot on my computer. So for me to locate them, I'll just go to my cache memory or just input the name of how I save the item on the computer. And the cache memory will just bring it out without you even going through a lot of opening, like a lot of applications or anything. Like you just put it in your search bar, then it will just bring it up so that you just get your item really quick. So that's everything about cache memory and mapping techniques. So that's the images behind me. See, we have is actually the same thing though, but let's say this one is the skeleton drawn type of the mapping and the cache memory and the colored or anything you call this one. So you see, this one is direct mapping. You see, this one is a block to a block, like one specific block. It's not maybe to any block or maybe um to so right now because we have block 0, we have block 1, then the set associative. So that's why we have the double lines at that block. Then we have block J, then block J plus 1, block J plus 2. So that's the main memory. You see, and that's the key. So let's say I've stored a picture of myself on block J. So right now, for me to get a picture, I'll just maybe how I save the picture. I save the picture with maybe my name, which is Michael. So I'll just input Michael. So anything about Michael on my computer, the case memory will just bring it out fast. And the only thing I've stored with my name is my picture is Michael. So to bring out the picture, then I just select the picture and the picture will open. So this one is just a direct mapping. So maybe I'm um going specifically for my picture. So that's how everything works. Thank you very much.